Hear me? Can you hear me well? Oh, hello everybody. Good afternoon. I think we can. It's time to start the next session. I hope you had a great lunch and are empowered and willing to listen to the great session of this afternoon. I would like to introduce two speakers for this session. Tomáš Tomeček and Jiří Podivín. They are both engineers working on a very exciting project, exciting for everybody who has ever tried to build a package and figure out why it doesn't build successfully. And I'm one of those people. So let's deep dive into how to inspect the logs automatically with LLMs. Please warmly welcome Tomáš and Jiří on stage.
Carolina, you were spot on because we have like 50 minutes of content and 20 minutes of time, so let's dive into it. So slide number one, Log Detective, that's what we are here to talk about. It's the project we are working on for almost 2 years. We had this idea and started doing some research, and it snowballed into now actually many things. So right now we have 2 deployments actually. One is hosted in Fedora Infra, and you can go to logdetective.com. That one is running on Fedora Community Shift, so you can use it right away. One of the functionality is that you can feed in your log and get it explained by AI, and it will tell you like what it thinks and give you some explanation and suggestions, which means that I didn't even say what the project is about. So Log Detective is an AI tool or service that can explain failed RPM build logs to you. It can probably work even with test logs or Flatpak builds or image builder logs, but we are right now focused mainly on RPM builds, so to focus only one thing. And one more thing I wanted to add for this slide was that it's already integrated directly in the Fedora Cooper interface. So if you are building in Fedora Cooper and you have a build there, and you look at the list of the truths, you'll see 2 buttons there. One is called Ask AI, the other is Teach AI. Ask AI is that you'll be forwarded to logdetective.com, and it will explain that log to you. It takes probably 2 minutes to do because, it's slow. Even though we are running on a GPU, it can take some time. And the other one is Teach AI, and that will actually gets you to the interface as well, but that gives you opportunity to annotate the log for us so that we can include it in the data set and we can use your contribution to provide better results. So Jirka, can you tell us more about how it works inside?
Okay. So it's actually very simple. Log Detective, as it is right now, is hooked up to our GitLab instance. Anytime somebody tries to make a merge request, and that merge request fails in CI due to, build failure, effectively, that activates a webhook, and we get a submission for the Log Detective to take a look at. Log Detective server does some very basic processing. It effectively uses just a standard template mining approach to extract the interesting parts of logs. Oh, sorry. Does it work? Oh, okay. So it uses template mining to extract the interesting parts of logs, or to be more precise, to extract the most significant samples from the logs. Those are then fed to the LLM, which tries to explain them all. As you can see in the, you can see it, I think. You can see how we're making multiple requests for the chat completions endpoint at the LLM inference server. So for each one of those small parts of the original log file that was deemed significant by the template mining algorithm, we make one request so that the LLM can kind of explain what was happening in that specific spot. Those are then compiled together and used to prompt the LLM one more time to give a final summary analysis, figure out what actually happened. Right now, what we're using to do that, we're using some of the models that are deployed on our internal infrastructure, but it's agnostic as to what kind of models you're using. You could hook it up to OpenAI offerings, Gemini, anything that's using the standard OpenAI API. It's pretty much, it's very simple. It's just a question of editing 2 lines in our config if you wanted to. And finally, when it gets that analysis done, it displays it to you either as a message on your merge request, or alternatively on that web interface that Tomáš was talking about previously. And since we are OpenAI API compatible, we can hook up to anything else, including VLLM. VLLM is actually offering almost entire OpenAI API as part of its interface. So any VLLM instance running is enough for us. Since we're using just 7 billion models, the 7 billion parameter models, it's kind of limited at what it can do. The bigger ones would probably work better, but it's still working decently enough. We're getting like reasonable, actionable results most of the time. Even if you quantize the model down to like just 4 bits, like the models are usually trained on 16 bits. So you're basically cracking down to 1/4 of the original size. You can still get useful results. So if you like want to, for example, deploy entire log detective, all the infrastructure, you can do it on your laptop. And that's actually how we're doing it for development. So we make a new change, we can just deploy everything on our laptop with Podman Compose and run the inference and get answers. Granted, if you do it on your laptop, it's gonna sound like an attack helicopter, but just for a bit. After that, it gives you a response and you can see if you messed up and you have to do it again. We have 2 modes there. The simple one, that's the original we have used, which basically just works by taking all the individual pieces of the original log, putting them into the prompt, and then asking the model, hey, what can you make of it? That's the original mode. Then we get a staged mode, which is what we're using now in deployment, which basically, as I've said, prompts the model multiple times to get the response. Once for each snippet, and then once again for all the snippets at the same time, which are already annotated. That integration we have with GitLab right now, it's working pretty well. We have a nice little account there for Log Detective. We can actually watch it making comments on all the merge requests. We are trying to make it better all the time. Right now, we have this feature there where you can respond to Log Detective. You can respond, obviously, as you would to any other commenter on your merge request. But what we're specifically looking for are emojis, thumbs up, thumbs down. So we can kind of record how people are reacting to it in the long run. The idea is that we would eventually use it to kind of fine-tune the model on the responses, so we could give it better, feedback and eventually produce something even better than we have right now. But in the short run, we're using it to judge whether or not any changes we have made to our deployment are impacting users. So please, if you have, your merge request commented on by the Log Detective and you like it or you don't like it, don't hesitate to respond there. That's what it's for. We're also adding a little disclaimer about this onto every comment we make. So it's very transparent and you don't have to worry about posting a wrong emoji or something. Now, about that template mining I mentioned, we're using something called Rain3 algorithm. It's something that's totally unrelated to LLMs. We have slightly adjusted the heuristics that it's using to determine where individual parts of the logs end and begin. That's because the original system was made to be used on continuous streams of logs, for example, from firewalls, trying to find the significant events. And it's not necessarily well suited out of the box for build logs, which are, basically they are long, but they're not continuous streams. They are in the files that are already existing, and also they sometimes contain messages that are split on multiple lines. So we need to account for that. But that adjustment itself is very simple. It's just like 10 lines of Python code. It works pretty well. By splitting the logs into those snippets and then asking LLM one snippet at a time what it thinks about them, we can achieve sort of quasi chain of thought behavior, even though we are not using a reasoning model. Because effectively reasoning models, those that are popular right now, all they're doing is that the LLM is first generating a bunch of text describing a fictional thought process. So here we're kind of doing that on the side by ourselves. And yep. So much.
Okay, so now you know who the mastermind behind the project is. So there was lots of text in a few slides, so let's look at some pictures. Sorry, we don't have demo because we don't have time for that, but we have screenshots of how it looks, what Jirka just described. So here, first we are looking at the merge request command that's on a CentOS stream merge request. I don't think I need this because I'm getting echo from
Yeah, sorry.
So when you contribute the microphone,
It should go over here and use them.
oh, okay. So if you contribute to CentOS stream and you do a merge request and your build will fail, this is what you will see in your merge request. This is the command from Log Detective. So you can see it's pretty long. That's definitely one of the bigger issues we are having right now, that it contains just way too much text, even though we tell LLM, like, please be concise. It's not. So we are trying to trim it down, but in the end, usually, like, the gist of the issue is there. Then you can see the 3 arrows at the bottom that can be expanded. So the first one, details, is here. That's what Jirka talked about, the snippets. That's how we extract the important lines from the log. And here they are. So it's usually the line in the log file, then the actual line, and then the explanation. So this is, like, I would say pretty useful if you are new to packaging or new to Linux. You can easily get explanations of every line here. And typically, one of the lines is the big reason why the build failed. And that has the explanation. And then we are doing the big query, as Jirka explained, to get the proper explanation. So you can exploit the details to look at this. And and finally, there is also that if you think it's right, please give it thumbs up. If it's bad, let's give it thumbs down. And we are aggregating this emoji feedback, so we know how we are doing. We know if we push a new update out, it's better or worse, because since LLMs produce always something different, it's very hard to test this system. I mean, we usually do an update, so we run some, we open some MRs and see how the feedback looks, and it's yeah, it's better, it's worse, so it's really hard to tell. And if you are going to the logdetective.com website, that's one that's hosting at Fedora, the interface looks like this. So it is split into 2 panes. This is the left pane that has the overall explanation. Again, very similar as to what you saw previously from the merge request command. It's still under the hoods, it's the same, it's just the interface is different, but this is on demand. You can go to that link and use it right now. But if all of you do it right now, I'm pretty sure that it will explode or something like that. We didn't scale this service up at all. And on the right side, you see the snippets and explanations of them. And thanks to Zbyszek, actually, he suggested that we improve it and we actually show the whole lines. I mean, we are not UX designers, so that's why it looks how it looks. I mean, we did try hard. But we would definitely need an overhaul at this point, to improve the interface. But again, it's very similar what you saw in the MR command phase. And we are at the final summary slide.
Okay, so all of the things we pretty much already discussed. There's only one thing remaining. We have an annotation tool for your logs. So if you have your build failure and you want to, resolve it, but not just for yourself, but for everybody, you can submit it to our annotation tool at www.logdetective.com. There you will basically perform manually the operations that Log Detective should perform automatically. It will describe what happened, how you can fix it, and just highlight the portions of the original log, as you would want Log Detective to do. That way you will contribute to our public dataset. It's published under, very open and non-restrictive license. So yeah, everything you put in there is gonna be public. So please, no submissions that are containing other stuff than build logs. We are gonna sanitize it, but it's gonna be available for download eventually. So we welcome all contributions, not just to the data set, but also to the code. We host everything on GitHub. We're appreciating any sort of feedback on the output, formatting, everything practically that we're doing there. And we're gonna have a workshop on Saturday morning. So if you want, you can join us for that, and we can, take a deeper look. And if you want to watch Log Detective at work, that one last URL at the bottom, that's the link to the user in GitLab. So you can check him out, how he's contributing. That's everything.
Thank you. Time for questions.
So thank you for that. It looks quite promising. I'm wondering how deep could you configure the model itself or the LLM from within the Log Detective config? So for instance, would you be able to configure the temperature of the model just from the Log Detective configs, or how do you tune that out?
I can manage. They can't hear me. Okay, so we have the temperature parameter available, exposed in the config. So you can just edit a YAML file and change that. You can just swap the model out just by pointing to a different URL as well. So that part's easy. You can also edit a prompt through a YAML file. So all of those things can be done. I would have to advise, however, that changing the temperature of the model doesn't have to be necessarily that effective. Like, it used to be that it was one of the parameters that determined the model behavior, but these days it's not having that much effect as it used to. So yes, you can do that. And also, of course, because we're using the OpenAI API to do the job, we can expose additional parameters up to and including all of those that are exposed in the OpenAI API. It's just a question of seeing a need to do it. So if you see something that's not exposed and you want to, just submit a PR and it's going to get there.
Another question?
I know you're using a 7B model, but it seems like you're not passing in other elements of the build other than the log. Beyond the fact that it's called Log Detective, is there a reason? Like I didn't notice in the snippets that you showed of it saying like, and on line 7, I can see that you passed in this, and that's probably the actual root of your cause, and it should have been that, as an example. Like, is there a reason there's no more context being added?
Does this mic work actually? Oh yeah, it works, perfect. Yeah, that's actually a very good question, Brian. I mean, yeah, we are only using the log file itself, like we are not passing any additional info, and yeah, I think it could be useful. I also think that we could also go to the sources and basically check out the sources and see latest commit or something like that and pass it in there. I mean, that could be helpful.
Yeah, you can do that. The problem is that if you're using a small model as we are right now, the model has fairly limited, and everybody here is familiar with the word context in terms of like, well, at least somebody is. The point is like, the context is like the memory of the model in terms of computing. If you overflow that, it forgets what was at the beginning. What's worse, even if you don't overflow that, if you approach that limit, the model starts to put less emphasis on what was at the beginning. And unfortunately, with smaller models, you get to that limit much, much faster. If we're talking about sources of like the package, you could maybe devise some sort of heuristic where you would pick out only the changed files and then you would pipe them into the model context, but you would need to be very careful about not to overflow that. You would probably need to employ additional heuristics just to chop off the not interesting pieces. And if by a chance you hit something that was important, it's often is that the packages contain more than just one file with source that's executed. So if that actual problem was somewhere else than in the file patched, yeah, it would increase the complexity a whole lot. And yeah, I'm not sure how quickly we could implement that, or if that's even like reasonably possible to do on what we have available. Yeah. So, but yes, it's technically possible to include other files as well. It's just that the models wouldn't handle it, not those we have right now.
Yeah, to me sounds like we would start turning it into an AI agent, like to actually be smart about what's happening and try to aggregate it and do something extra, which, I mean, yeah, we could do it, but it's much more work than just this.
Hey, I might have multiple questions, but I'm gonna try not to ask all of them. So, from the description of the log detective, I'm thinking like, is it efficient to use like one general model instead of, you know, all the like suitable embeddings and re-ranking and vector databases and all of that? And yeah, the other question would be like, aren't there existing products? Are you not reinventing the wheel? And I guess the third one would be, how do you do evaluations? Like, you know, how do you know that you're improving?
Okay, so that's 3 questions, really. I'll start with the first one, reinventing the wheel. That's the second one. Okay, the second one. Well, it doesn't really matter. I'll start with that one. The point is, no, nothing like this, quite this exists, not with the GitLab integration. And the closest analog would be copy and pasting the log into a prompt window of your LLM agent or chatbot. Or you could try Copilot, which didn't exist 2 years ago in the form it exists now. I guess that may work. But none of those alternatives are open source in the same way, and none of those can be controlled as well as the log detective can. So no, I don't think there's anything that quite fits the niche. The third question was how we're seeing if we're improving. Well, that's what the emojis are for. There's no way, literally, like it's very difficult, well, not no way, okay, that's maybe too broad, but it's very difficult to measure performance of LLMs on any actual tasks. All of those metrics that are commonly employed, starting from Perplexity and ending with various chatbot arenas, they are very easily subverted and toyed with. I've seen papers on it, and it has been done before, and it's done now. I mean, there are some things you can check for relatively easily. For example, if you give it yes or no questions and restrict it to that one kind of response. If it's binary, you can easily measure if it's going wrong or right. If you're going for long-form text and trying to measure that, things get tricky very quickly. And automatically measuring it, it becomes more and more problematic. Also, if you want to do that and you want to turn it into a CI, you need at least one additional deployment of the system somewhere running that will not be ever queried by your users, which is something we just don't have resources for. We would need to spin up additional log detective instance somewhere else for everything. Then we would need to launch a barrage of tests that, as I've just noted, are not always extra accurate, and then we would need to get some sort of, you know, measurement of the accuracy from that. So that is making the whole proposition kind of, yeah, not so easy to do. It's easier to do if you have like a deterministic computer program. There you can just launch unit tests, integration tests and such, but this just doesn't behave the same way. Although it's much more expensive to run. So what was the first question again? Okay, so it wasn't important.
We have questions from the...
Okay.
Okay, so first one, is there enough data for to train a machine learning model rather than using an LLM which may have data origin concerns?
Well, as we have described and I mentioned...
You need to repeat the question because...
Oh, there wasn't... You have a microphone.
I have
He has a microphone.
It was not... Can you open it? It's not
Okay, so...
It's turned on. Oh, okay.
Okay, so... I don't remember the question anymore, so... So what was the...
Okay, it's working.
Yes!
Is there enough data to train a machine learning model rather than using an LLM which may have data origin concerns?
Okay, so no to that first question, and that's why we've said several times that we're gathering data. And because we're gathering the data on the license that everybody who contributes to the data set agrees on, we don't have concerns about the origin of the data necessarily, because we know the origin, we are the origin. So that's, I suppose, an answer to that. If I understood the question correctly.
I hope so. It's from chat.
Anyone else? Any questions?
We have another one from chat. So.
Okay.
Apology if this has been covered. I missed the beginning. But what is the accuracy of this from your experiences?
Okay, I would say it's generally accurate when it comes to simple issues that pop up during the build. For example, anything from missing packages, bad options for the compiler, stuff like that. It can pinpoint those very easily. If it's anything more esoteric, then it can be tricky. It gets worse at that point. There's also the point that if by any chance, whatever the line, if the information about a failure isn't in the build logs, or if the information doesn't get extracted by the template miner we're using, then the LLM has absolutely no hope of figuring it out, because there's no information available to it. It's not magic, it's just an LLM. So that's the limit. So I guess those would be the failure modes, if it's not in the build log or if the template miner can't pick it out.
Thank you, Jiří and Tomáš. You can ask more questions in the foyer during the break. Thank you for your attention. And, do we have Dan Walsh here? Okay, then we'll be surprised. Hopefully, at some point. Okay, as far as we know, the speaker has not registered to the conference yet, so I'd say the chances of him appearing soon, very soon, are rather low. We are trying to contact them and figure out if he's coming, but for now, I guess we've got a break, or you're welcome to join other rooms for other talks. Hello, everybody. Welcome after a very, very short break. I hope you enjoyed. We are just on time to start another talk, so let me just pass the word and let's welcome Dusty here on stage talking about the future of Fedora CoreOS.
Thank you, thank you. I'm not going to spend much time introducing myself just because I don't have a lot of time. So my name's Dusty Mabe. I'm an engineer at Red Hat, and I'm going to talk about the future of Fedora CoreOS. So what's the agenda for today? I'll talk a little bit about recent developments in CoreOS, like over the past 6 months. We'll talk a little bit about metrics. How are we doing? How many users do we have? And then I'll get on to the future, and we'll talk about things that are coming down the pipe. And hopefully we'll have some time for questions. We'll see. So recent developments. So over the past 6 months, we actually completely overhauled how we build disk images for CoreOS. Downstream, Red Hat uses a technology called OS build. And in CoreOS, we had some very custom scripts to create disk images in our CoreOS assembler SDK. But we overhauled, and now we use OS build to build all of our disk images, and that was a pretty big change, but hopefully nobody in the community really noticed anything different. We also switched newly deployed nodes, so if you were to spin up a new Fedora CoreOS node today, it uses the OCI registry for updates, whereas historically we've used an OS tree repository for updates. So we're pulling updates from the registry now. We also added the Hetzner platform, so we have disk images for Hetzner and docs on how to use those. We added KubeVirt images for S390X, whereas previously we only had them for x86-64. And we have a couple things in progress, like switching existing nodes to OCI updates to complete that transition. And then Proxmox enablement. We've had quite a few people from the community asking for Proxmox, and we are about halfway done with that right now. So, you know, just from the past 6 months, we touch on a lot of different platforms and technologies, and we're just adding to, you know, the large group of ones that we already support, which is kind of nice. So how's this turning out? You know, how many people are using it? Luckily, we have the Count Me stats in Fedora that help us, you know, look into this information. So for, you know, all of the nodes that we have that are out there, we have about 110,000 total. About 2/3 of those are CoreOS instances that have been around for longer than a week. And then about 1/3 of those are transient nodes. We call them transient. So they've been around for a week or less. So they could be new nodes that are going to be long-lived, or they could be like batch processing or CI type stuff. We're not quite sure. But, you know, cloud use cases, burst up, burst down type stuff. By Fedora release, so right now we only have a thin slice of Fedora 42. We only recently, 2 weeks after the Fedora 42 GA, switched our stable stream over to Fedora 42. So there's a little bit of delay and uptick there. A lot of them are on Fedora 41. We've got a lot of Fedora 40, but when you dig into the metrics on that, it looks like a lot of those transient nodes, about 20,000 of them, are actually Fedora 40. So like, to me, that indicates we've got one really big user that likes Fedora 40 for their batch processing, and that kind of helps pad the stats for Fedora 40. But we have them running all the way back to Fedora 35. What we'd like to see is most of this graph be Fedora 42 at this point, because that's where our production streams are. Matthew. Yes, so the question is, do I know how many of these are Podman desktop? We don't know exactly, but I do have an indication of that, which I'll talk about here in a second. But they're not broken down right now in the Count Me stats based on CoreOS or Podman machine. But I will talk about architecture now. So this last time, looking at the stats, is the first time ARM64, AArch64 has actually overtaken x86 as the most popular Fedora CoreOS architecture. We do have some PowerPC and S390X nodes, but those are mostly, you know, not statistically important for this graph. So 52% are AArch64, 48% are x86. And I think a big part of that is because of Podman machine. because Podman Machine, one of the primary use cases there is for Mac developers, and a lot of the new Mac hardware is AR64 only. And there's other things like cloud platforms offering AR64 instances that are line by line cheaper than x86 for the same compute, right? So as far as comparing like cloud, CoreOS, and server from a like total node count perspective, cloud has a lot of variance any given week, and that makes sense because cloud workloads typically, are burstable. If you were to dig into the transient node count for cloud, you'd see that, up 100,000, down 100,000 per week. But if you look, we have pretty steady growth compared to cloud and server, just in general. Okay, let's talk a little bit about the future of CoreOS, and I can't really talk about the future without talking a little bit about a technology called bootc. If you were in the Bazzite talk earlier, they mentioned it a few times. But let's talk a little bit about what is bootc. So I like to break it down into two separate categories. One is the bootc technology, so the actual software, the binary and bin bootc. And then the other one is the bootc base images. So these are the actual container images that can be used as a building block. And what is the bootc software? So it's very similar to RPM-OS tree. You can run bootc status, bootc upgrade. You can do various other things with, with the tool itself. And here's an example of running bootc status to show, what's provisioned on your system, bootc upgrade to show if there are updates available. And then there are the bootc base images. So these are actual container images pushed to a registry. There's ones for CentOS, there's ones for Fedora. But what are these useful for? They're for building your own. So in this example container file, we're building from Fedora bootc. We install Apache or HTTPD. We configure it, and that's the container build. And you can then deploy that on your machine, and Apache is running directly on the machine, not via container. So the point of the bootc base images to me is more build your own. And what is the future of Fedora CoreOS? Well, I think we want to leverage both. The bootc tech, because it has active development and exciting new features are coming, and then also the bootc base images. So both. So as far as the bootc tech goes, there's a feature in bootc called logically bound images that I think is interesting. So in this case, bootc will ensure a configured container image or images are bound to an update, meaning the update won't proceed if it can't go out and grab those images and verify them as well. So this kind of lets you piece together, an update from various sources, which is kind of neat. In this example, the container file adds quadlets, which are a concept in Podman. There's a Podman generator with these text files that will generate systemd units to run containers. And so in this example, we have a .image quadlet file and a .container quadlet file. And that's something you would normally do on a system anyway to run a container. But in this case, we also symlink them into a directory that bootc knows about called boundimages.d. And if you do that, when bootc does an upgrade, it will actually go out and grab those container images and store them in bootc's container storage essentially for you. So that's kind of cool. The next one I'd like to talk about is out-of-band configuration management. So this is a future feature that exists. Well, doesn't exist, future feature. But in this case, the idea is you use things like config maps or overlays to apply some small amount of extra configuration to a system. So you don't have to necessarily have it built in the main container image every time you want to deploy a new piece of configuration. So the three examples I have here, and the formatting on that one is kind of interesting for the middle, but the three examples I have here are one, an actual config map, so a config.yaml. The second one is pulling an overlay from a container image. So you just add a few files to your container image, and wherever they are in the file system, they'll get overlaid. And then the last one is actually doing that same thing with an overlay from a GitHub repo. And then, we are CoreOS, so we want to do things more declaratively via ignition. So something via ignition could look more like this, where we have a butane config and you specify your config maps or your config overlays that way. So in this example, we're using a GitHub repo with a main on the main branch of that repo and just telling CoreOS, hey, apply this on first boot. Another feature that we're interested in, and we've actually been interested in this for a long time, but we never got around to implementing it in RPM-OS tree, is factory reset. So essentially being able to reinstall in place with an option to keep your data or discard it as part of that install. So this is useful in bare metal environments or really any environment that isn't easily provisionable, right? So some people have everything automated for their provisioning, and some people you literally have to, upload an ISO to a virtual media server or an ILO or something like that, and like clicking the buttons takes a long time, and it's just a painful process. So being able to make that easier for people is something that we've wanted for a long time. The other one is confidential compute, and every time I talk about or read about or think about confidential compute, I always end up back on like Wikipedia or something trying to figure out what it is again. But I'll try to summarize a little bit, and I'm sure some of this is wrong, but with confidential compute, if we have something called a UKI or a unified kernel image, which is a combination of a UEFI stub program, the Linux kernel and the initRD, and the command line arguments. So all of that gets bundled up into a single file, and then we can sign that file. So you get essentially secure boot-like guarantees, but with your kernel and your initRD and the command line arguments it gets started with. And chaining that into the actual booted system, we can use those command line arguments that are signed to pass that on to tools like ComposeFS, ArrowFS, and FSVerity that can then verify what you booted is actually what the signed UKI said we wanted to boot, right? And that's about all I know about confidential computing. If you want to know any more, ask Timothy, because he knows a lot more than I do. But I think the summary of this is that all of this enablement work for these new features that are coming up in the industry is happening in bootc, and we want to take advantage of that. The other one is not necessarily bootc specific, but it's systemd system extensions. They allow for you to deliver some extensions to base software, which is an overlay on top of like the /user directory. And they can be merged and unmerged on demand, which means you can essentially hot plug them in. But really, bootc can help us manage these things as part of an OS update, right? So they're not managed separately. They're managed kind of like the logically bound images that I mentioned earlier, along with the update. So there's an open issue for that, kind of tracking that work. And then like as far as just CoreOS and systemd system extensions in general, Timothy's been exploring these from that perspective, and also Atomic Desktops. And he has a nice website which I have linked at the bottom and also on the previous slide, that lists a bunch of extensions that he's built and also how to apply them. So if you don't want to wait for bootc to support this, you can go ahead and test these out today, which thank you, Timothy, for doing some of that enablement work. Okay, so on from the tech and on to the base images. Ultimately, CoreOS doesn't have to move to bootc base images, right? As far as the users are concerned, the end user experience should stay the same, whether we continue to build our base images like we do today or whether we inherit from bootc base images. It's an implementation detail. But the goal here is actually that we leverage the shared base image with other Fedora additions. So we can bring our CoreOS tests to build out the bootc base image CI. Other Fedora SIGs can contribute their own tests, and we're all working on them together. So structurally, it makes sense for us to organize that way. But like I said, it's mostly an implementation detail, and hopefully the users don't see a difference. Okay, so what is bootc missing? As I mentioned earlier, we're moving to OCI-based updates because bootc really it doesn't understand an OS tree repository for an update scheme. So there's no more distributing updates via OS tree. We're already migrating away from OS tree for updates. There's also less info about the content inside of a build for boot C. So RPMs aren't tracked like they were with RPM OS tree. And that's partially because boot C is meant to be OS/distro agnostic. So you could build a Debian boot C image, etc. But the one big feature is package layering. So a lot of CoreOS users, including myself, might add a package or two that we want on the system. And this is a major feature for Fedora CoreOS that we can't really leave behind when we move to boot C. So that's something that we're working with the boot C team on to try to make sure that exists. We can't remove RPM OS tree from our CoreOS images until that's a feature that exists. And we're talking about doing that in like a plugin based model, so there'd be like a plugin for DNF. We also have client-side init-remfs generation/tracking in RPM OS tree. That doesn't exist today in boot C. So that's something else that we might be able to implement with like a local layer plugin model. All right, let's talk about community strategy. So I think boot C and CoreOS really complement each other. So from the beginning, CoreOS has always had people that come to us and they're like, we want to build our own CoreOS. And we're like, that sounds great, but it might be difficult. Just because, when we built the tools to build CoreOS, we didn't design them with end users in mind. We just needed to build a tool to do the thing. So CoreOS has been more concentrated on directly consume, the direct consume use case. So you provision our images that we upload to start your nodes. Your applications run via containers. You follow updates from our updates that we publish and the update graph that we publish. But boot C is very much more build your own use case. So it's exactly what you need and nothing you don't. Your apps can run either as containers or directly on the host. The example I gave earlier was directly on the host. But you also must create your own build pipeline for updates, right? You own it now. In the future, maybe you can build your own update graph if we make the tooling work for that. But essentially, this is shifting user responsibility, right? So CoreOS, you can try it out. If you're happy, you can keep using that. But if you really need something more or different, you can make your own. But you kind of take on more responsibility as part of that. You move to the right over here. And for example, like Bazzite, uBlue, they're building their own. They have their own pipelines that they push to a registry, et cetera. And this is nice. So we have both sides of the spectrum. We have CoreOS for kind of the more pure, you're using what we produce, and then we have boot C for more of the, build your own, distribute a brand new thing. But I think it's really a spectrum, right? We're providing a full solution for the community, whereas on the left-hand side of this spectrum, you're using CoreOS, you're using the vanilla images, you're using the update graph, you're running a few containers and you're happy. But now we step it up and we say, oh, well, CoreOS works well, but I need just a few files changed. I need to configure something differently, and I need to manage that configuration over time. That's where out-of-band config management comes in. Next up, maybe I want a little bit extra on the system. Maybe I want the vert stack instead of a container stack. CoreOS with systemd system extensions, right? Or if that doesn't work well for you, you can do local RPM layering like we have today. But then say you get to the point where you've tweaked CoreOS enough and you're like, this would just be easier if I was building my own thing directly, right? So you step over to build your own, right? You step over to using boot C-based images directly. And then maybe you're distributing that image to a bunch of people or a bunch of different systems, and you want to tweak each one of them independently. So build your own with out-of-band config management, right? So there's a whole spectrum here, Goldilocks, right? So you can find too hot, too cold, exactly what you need with CoreOS and boot C together. And I think that's kind of how we will end up in the community eventually, is kind of working more together upstream with boot C and CoreOS, and maybe even being one and the same at some point. Let's see, I'm almost done. Yeah, questions. Am I good on time? Pretty good? Okay, nice. Does anybody have any questions?
Yeah, if you are using OCI images, if I understand it correctly, Basically, that means that you should be able to take Anaconda to install CoreOS this way and just use Kickstart with the OS3 container or future Bootsy install command.
So today with CoreOS, we have disk images that we build, and each one of those disk images has the same exact partition scheme, data that's written into it. There's like one small piece of data, which is the ignition platform ID, that might change between, like, if you're running on AWS or GCP or bare metal. But those are all the same today. And so if we were to use Anaconda to deploy CoreOS in the future, we'd have to modify some of our assumptions about the way the disks are set up, or we'd have to bake in like a configuration so that Anaconda would know how to set up the disk in the same way. But it's definitely possible, especially because today with Bootsy, you can use Anaconda to deploy a bare metal system from a container with Bootsy. So we'd have to change some of our assumptions, and we might do that at some point. But right now, you know, the recommendation is not necessarily to try to deploy Fedora CoreOS using Anaconda. It's to use CoreOS installer or DD or whatever to continue to do that. Yep.
Love your talk.
Thank you.
Very exciting stuff. I'm also a big fan of Google containers.
Nice.
My question to you is, in your slide you just presented about Bootsy and CoreOS potentially coming one and the same, or sharing a lot of features.
Yes.
I'd like to know, in your opinion, what would like the best case future vision be for Fedora CoreOS or Fedora server as a Bootsy atomic, because 2028 strategy really seems to go in on Bootsy as a technology.
Yeah. I think, it's kind of what I presented at the end, right? Like, at least from an end user perspective, right? The end user has options. Now, we should present these options clearly to the user so they're not confused. But the end goal is the end user has options, right? Now, do we structure ourselves in the community in the same way? For example, will there be Bootsy docs and CoreOS docs? Or will we have some sort of combined strategy there, right? Where the Bootsy docs and the CoreOS docs are essentially the same thing, but they're presented to you based on what you want to do, right? So I mentioned the direct consume versus the build your own. So that's kind of where my thoughts are around that, and like getting caught up on like, oh, well, are these the CoreOS docs or are these the Bootsy docs? I think that might be not the point necessarily, but the point is to present it clearly to the user so that they make the right choice. And some of the other stuff is just details, right? I don't know if I answered your question, but yeah, we can talk more if I didn't.
Do we have any other questions? Okay, if no, thank you, Dusty, very much for your talk.
Appreciate it.
And now we can head to a refreshment break that will take half an hour, so enjoy. Welcome back after the break. Let us all sit in and let's welcome Timothy, who will tell us all about atomic desktops of Fedora.
Hey, check. Is the mic okay? Yeah, mic works. All right, everybody, welcome. So first, why should you even listen to me in the first place? So who am I? I'm a CoreOS engineer at Red Hat, working on Fedora CoreOS on the work side of things. And on the side of the community, I'm the Fedora Atomic Desktops maintainer, mostly working on Silverblue and Kinoite. Has been for a while now, for a few years. I'm also a KDE SIG member in Fedora, and also working on KDE as a developer and as part of the KDE FlatHub team, which works on maintaining the KDE apps on FlatHub. So why are we here? We're here to talk about Fedora Atomic Desktops, but quick refresher for those that don't really know about the Atomic Desktops. What are they? Well, the idea is they are an image-based version of Fedora. So we offer a bunch of different desktops, different options. And the main thing that you have to remember is that they are built from the same RPMs as Fedora. So it's not just like something completely different. It's very much Fedora. It's part of Fedora. It's built with everything that is in Fedora. So there's no magic in there. The main thing is that they update it as an image. So instead of updating each package one by one, you update the whole desktop as an image, the whole system as an image. It means that you get super nice properties. So it means that the updates are either applied or not at all. Like you don't get things half in half. They applied in the background, so you don't need to wait when you reboot for the new updates to be applied. You directly get into your new desktop. And finally, you can always go back. That's like nice, super nice properties when you update with an Atomic desktop. If whatever fails, your kernel doesn't boot, your graphic cards doesn't work, it's all right. You can go back to the previous version, which hopefully worked because you were using it first in the first place before the update. So yeah, the nice thing that comes after that is that any update ever on your system is behaving the same way. So when you do an update to a major version release, new major version of Fedora, it's just like any other update. There's no difference. It's like you don't see any difference. It's just a bit longer. It takes a little bit more time to download. But apart from that, it's the same thing. So once we've said that, okay, all right, we're in Fedora. We have super nice things around updates, but do we actually have users? So thanks to the community support, we can now say, we can look at like approximately how many systems we are running. If you look here at the graph, there's like two colors. The bottom part is like the systems that are at least 1 week old, so hopefully there are systems that have been installed for a while. And the color at the top is the new system. So either it's people trying out and not sticking on Atomic desktops, or it's just potentially new users that going to new systems that going to be lasting longer than 1 week after that. So like the first part is a little bit transient, fuzzy. We'll see that. And if you look here at the graph, there's like, what's happening here in this drop here? It makes no sense. Why are we losing all of a sudden a ton of our users here at this point in the time? It's around July 2024. Well, here I want to make sure you look at the left at the y-axis, at the number here. We are about 10,000 users here. If we go here and we take a look at now with systems that are what we call our downstream friends, which are essentially Universal Blue, and we take them out in the picture, have them in the picture, then we now go back from 10,000 users to about 30,000 users in total. So Universal Blue is a huge part now of the Atomic desktops. So they are not directly in Fedora, they are downstream of us in Fedora, but they are based on the Atomic desktop. They are using the base images that we built for the Atomic desktops. So which one are popular? If you look at the stats, you can see that essentially Basite is taking a huge chunk of that popularity about all variants that we have in the Atomic desktops. Then comes Silverblue, then comes Kinoite, and then comes all the Universal Blue variants of those two. So Bluefin is based on Silverblue, and the Aurora is based on Kinoite. And then you've got a bunch of the other ones, whether in Fedora or Universal Blue. If you look at the release breakdown, which is like really nice. Until I actually did this one, I didn't know what the release breakdown would be. And so if you look at that, we got about half and half, which is huge in a sense, and it's pretty also up to date. Like people are running the latest ones, and we're really, really close to like having a good chunk of our users using the latest stuff. You can see like there's like 2 small bits here at the bottom, which is like, what happened here for those users? Like we got an F42 one and an F46 one. It's like, why isn't an F39, 37, 38 in the middle? It makes no sense. Well, it is actually, if you take a look at here at some of the bugs that we had in the past, where essentially for those 2 releases, we had update-breaking bugs. We had bugs that people had to manually fix to update their systems. So it means that here we're losing users. Those users are not updating their systems because we had this update-breaking bugs. Everybody else is updating, essentially, but those are not because, well, they've stuck there because we broke the updates for them. So like the update thing is very much like core to the Atomic desktops, core to what makes us work well and makes us also likely popular. All right, so with that said, I hope we could find some way, but it's super difficult to fix them. So I guess they will have to figure it out. Or watch this talk, maybe. I hope so. We'll see. So with that said, let's take a quick dive, a quick look, a quick side road to Universal Blue, because it's super interesting to know, to look at what they're doing and see how that reflects on us and how we could do things differently, potentially, because they are a big chunk of our users now, essentially. We can, like, they're using something slightly different, they are downstream from us, but they're directly benefiting from the work we do in the Atomic desktops. And so I really consider them as part of our user base. So Universal Blue, as I've said multiple times already, they are a downstream variant. They have multiple variants, so based on the silver blue, keen white variants, etc. And the main one is Basalt, which is focused on the gaming use case, on the gaming handhelds as well, which is why it's also so popular. Bluefin and Aurora, they are kind of desktop-like variants, and they also have developer-focused ones. So like the variants that where you install the system, you have all the developer tools that you would ever need or want to use, all the classic stuff. Now it's VS Code, Docker, etc. All the tools. They are pre-installed, so you don't have to care about installing them, setting them up. It's all there. You may not use everything, or you may not use not one all of them, but like for some developers that are getting started, it's easy because you get the thing, you get everything, and you use the one that you want. The other ones you just leave on the side. And finally, there's uCore, which is kind of a variant of Fedora CoreOS. We don't know yet how much it's part of the Fedora CoreOS. They are changing their variance ID so that we can figure out in the company stats how much actually uCore user there are. Right now, we don't really know. Hold on. Yeah, they have variants for other desktops, but like they're a very small share. So the main thing is that they are not directly using the Atomic desktops as you know them from Fedora. Essentially, that's the trick. Like if you install Silverblue right now, it looks the same, but it's not exactly the same. The trick is they're using the bootable container images. So what is bootable container image? Well, I'm glad you asked. So bootable containers, and well, we showed that to Bootsy. Bootsy is a tool. Bootable containers is like the general technology. It's an evolution of what we have in OS3 and RPM OS3 and what we're using right now if you install a Silverblue system or a Keen White one, an Atomic desktop. The basic idea of a bootable container is that we're taking the content of the OS and we put everything inside of a container image. It's a standard OCI container image, so you can put that anywhere on the registry, etc., do builds with it. It behaves exactly like a container. It has a kernel inside of it. That's like the major difference in the Linux firmware, which is like a big package. But then the trick is that you're not using this container as is on your system. It's extracted. The content is extracted and put down onto your file systems on your system by bootc or by Opal registry, and that's like what you actually use. So like you're not running the container directly, you're not booting the container directly, you're like extracting the content on the disk and using that content. But like the cool thing is that everything, the updates happen via the containers, the modification, the distribution happen all with the container stack. So why bother with bootable containers in the first place? Like, we have Silverblue right now. It works. We're using it. We've got tons of users. Why do we even bother about this new stuff? The idea is that OS3 is great, but it has two slight downsides. The first one is that hosting an OS3 repository is a bit custom. You have to know how to do it. It's not super complex, but it's sufficiently different that it makes it difficult for a lot of people to do. Even for me, like when I got started with it, it was like a struggle to get things set up. It's not that complicated, but it's sufficiently different from Git, sufficiently different from other things that you need to learn to do with things, etc. When you look at an OCI container, we've got now tons of container registries that you can push your container image anywhere, and there's like plenty of options to use container registry. So it's not difficult to do that because there's already plenty of options, plenty of software, plenty of offering, etc., etc. You don't necessarily have to do your own on your own. The second one, I missed the order, sorry. The first one, that was the second one. The first one is that it's much easier to make your own. Right now, if you want to build your own OS3 Silverblue OS3 variant, your own Atomic Desktop variant, then it's kind of a specific process to use that, etc., and that makes things a little bit difficult to get it started. And so more than just building the base one, if you want to make a derivative, and if you want to change like just a couple of files and offer that as an option, it's really difficult. It's not impossible. It's very much possible, but it's more difficult. So, and the container files, the container approach makes that much easier. You can take a container image, do container build, and change a few files, and offer that as an option for people to use. And so that's like the two big strengths that this model has compared to the current OS3 model that we have in the Atomic desktops. So I think I've made a presentation about that at DevConf. I think it was last year. It was like, with this tag, you can make essentially a new project, new distribution without recreating a new distribution, which is like what we want to have here. We want to go away from everybody making a new distribution because they want to change 5 packages in Fedora. Instead, they should make a derivative image based on something that we already have in Fedora. With this 5 package change, that's fine. So why is, in the end, why is Universal Blue successful? But there's a few things that make Universal Blue really work well, and especially Beside. The first is that they do a lot of work around hardware support and codecs. So they have better hardware support because they're integrating proprietary drivers. So this one is what it is. And they also do a lot of work to make sure that the handhelds work well, which is where Bazat is mostly used. A lot of those are that. And then finally, they include all the codecs by default in the image. Another bit is they have FlatHub only Flatpaks by default. This is the largest source of Linux application right now. It mixes open source and proprietary, so you get everything in a single place, and it really solves the application distribution problem. So that's like the huge boons huge bonus with FlatHub. And that thing which is great with FlatHub is that a lot of those applications are also maintained now by their own developers. So you get a direct link between the app that you get there and the person actually developing the app, which is great. Another thing that is good with Universal Blue is that they have automatic updates. So like if you leave a system on and you keep using it, we will get the new version at some point automatically. It's something that we have kind of a little bit in the Atomic desktops, but it's not exactly as advanced. The models that they've implemented is very similar to the Fedora CoreOS model that exists in Fedora CoreOS. The idea is that you don't want to manage your system and update them manually. You don't want to care about that. You want a system to do this for you. But to do this for you, like it needs to be reliable. You need to be able to trust that the next version isn't going to break your system, essentially, that you're running. And for that, you need what we call streams. You need to be able to say, okay, I'm going to give time out to users to use something, to use a new image, try out things, make sure the graphics card work, etc. Be able to report problems if they have them, and do all of that like before I release the new update to people. And so that's like the idea behind streams. You instead of releasing something every day, you take time to give out an image that has been baked a little bit, that has been tested by people before sending them out to everybody. And the other big thing that they're doing is that they're very careful about how they do kernel updates and when they do the kernel updates, especially when you change minor versions of the kernel. Well, when you change version of the kernel, the main version of the kernel, there are frequent regressions, and so they do a lot of work around testing that and make sure that the things don't break, which helps them a lot. So really what they're doing is they're taking full advantage of the model of the bootbook tuners and combined with the Fedora CoreOS mindset around updates, it gave them something that really works. It proves that like this model really works because you can deliver software that automatically updates to people and at the same time keep them updated and also don't make them afraid of updates. So it's a major story for us, major success story for us, and it works well also because like we work well at the beginning as a base. So the idea would be, hey, why don't we take some of those things that they do, and maybe we could bring them back into the Fedora Atomic desktops so that we could improve how we do things. So first, like, get this out of the way. There's things that we'll never be able to do for licensing reasons, etc., and codecs, and so like we can get that one out of the way. The second thing is the Fedora Flatpaks. So it's kind of like the elephant in the room every time we talk about this, is that the Fedora Flatpaks are just awful from a user experience perspective because they are slightly different. They don't behave exactly the same way. They are not maintained the same way. They are not documented. There's no documentation. I don't know how to build a Fedora Flatpak. I'm like a Fedora developer. I've been there for a while. I maintain this stuff. I don't know how to build one. The format that is used is different, so it's different from FlatHub. It has different downsides, etc. It's only used in Fedora. Nobody else uses it. So essentially, they are not liked by people because like you don't know how to work with them. And so they sure technically are slightly better than the one on FlatHub in very specific cases and specific conditions, but it doesn't matter for the like 90% of the use case. And so instead what we should do is stop this experiment and instead work on bringing Fedora FlatHub Flatpaks as a first-class citizen on Fedora. So I have a change proposal here at the bottom that doesn't exactly do that, but like is a first step somewhat to get to that. The next thing is that testing in Fedora right now is difficult for various numbers of reasons. The first one is that the tools that we have, they are great, but they are developer-focused. They are packager-focused. They're not user-focused. Users don't test out packages. They test a version of the system. You give them a version, they say, okay, it works, it doesn't work, and then you give them another one, etc. That's like how Flatpak works. You give them a version of your application, and they tell you if it works or not. They're never going to look at the source code or figure out that this version of the package works, etc., those things. So those tools are great for us, for developers, but they're not great for users. So what we need to do instead is slow down the release cadence of the Atomic desktops. Slow down so that we get time to look at things. We get time to give out a version of the system to users, let them test it, and then find time to report the bugs back to us. Right now, when something lands in Fedora Atomic desktops, the next day, potentially everybody could have that version, and if it has an update-breaking bug, we hand back to the cases where we see at the beginning, where we have users that are never going to open a terminal and paste a command line because they have no idea what it means for them. So yeah, the fact that we build every day, release every day, and push that out every day to everybody is a huge downside for us. We need to slow down the release cadence. To do that, we also need to add streams. So and one option to do that is copy, essentially, like replicate some of the Fedora CoreOS model and add streams, the streams logic, to the Atomic desktop, so that we can have a stable stream that moves a little bit slower, that most users will likely be running, and then have some form of testing streams that we could use, that we could do more frequently, and have more advanced user tests and see how the things work, and then report issues and all those things. We have to make this be something predictable so that users can rely on it. All of this is great, but it requires a ton of work in the Fedora infra. Right now, the Fedora infra is really not suited to manage container-based operating systems. Unfortunately, so like there's a huge amount of work to do there, a huge amount of work around signing. Right now, you cannot just sign container images in Fedora, which is crazy. There's no way to manage the tags except filing a relaying ticket. I'm not going to file a relaying ticket every 2 weeks to get an update for the Fedora Atomic desktops go to stable. That's not scalable. So yeah, this is like a huge thing that we'll have to figure out somehow in the Fedora infra. Maybe once we move to Conflux, to Forgeo, it will make things easier. I don't know, we'll see how this works. I hope that we can bring some of the nice stuff from there. All right, so to close it out, now how do we actually make all of those things? All of those things happen. The main thing I think that we need to have is kind of like a perspective shift, a mind shift on how we work on things and how we deliver things to users. Right now, Fedora Linux, as much as we want, has been a collection of packages, and people like use it like a Lego box. They build the tool, the thing that they want out of it. They compose the things how they want it, but that's not what we can give out to users. Users are using like all the tools around package management, etc. It's not something that we can give out to users if we want to extend our reach. And that's why Biosite works so well. They don't ask users to care about package management. They bring them an image that works with all the tools included inside directly. If we want to reach people that don't use Linux yet, we have to work on this. We have to change our mindset from delivering packages to delivering an experience, a coherent experience, a current image of the system directly to users. One thing I get asked all the time is like, but like, at some point will get removed. Will we remove all the RPM packages, etc.? Stop doing the RPM packages? No, it's not going to go away. The RPM packages are still going to be there. The other variants are still going to be there. If we want to make things, the Atomic desktop the default, even if we do, they will be there still because they are the right unit. But we need to find out like which point we think are the blocking thing in the experience, and then work on them, fix them, and then finally decide, okay, let's go and make it the default. All right, I'll stop here, and here's a couple of links that will reach us, the Atomic desktop thing, etc. And of course, happy to take questions.
Thank you, Timothy.
First of all, thank you, Timothy, for doing what you have actually. Thank you for everything that you have done for us in the last few years. I do have one comment and one question. First, comment about the Fedora Flatpaks, because they sort of do have a use case and a valid use case. Basically, we have to ship Silverblue, in our case, with a set of predefined applications. Basically, there has to be something in the system. So that's definitely like that well-limited cases. Yeah, I know, but... yeah.
It's in the proposal. It's in the proposal.
Still, people here might not be aware. And the question is, if you go back a few slides about the update, so can you remind me how it looks these days with the Delta updates for OCI containers? So basically, when you are updating to a new version of Bazzite, you basically have to download the whole container.
So,
big one. Because I know there's still some, there's a pull request from Owen and Alex from 2020 that should bring the Delta support for the OCI-based containers. So basically, what's the current state?
Yeah, so the question around updates is with OS3, the way OS3 works, you only download the difference between the system you are running and the latest version. With the OCI containers, you theoretically would have to download everything, except there's something different in the way those containers are built, in that they are split into layers. So like when you have an OCI container image of an Atomic desktop, there's like about 56 layers by default, and you only download the one that changed. So you don't have to re-download everything. So you still download a little bit more than what you download right now using OS3 because it's less network efficient. But in terms, it's not the full thing. We can increase that number, so potentially you get more fine-grained downloads, and there's also work on like doing like in middle layer splits, etc. Right, work on that. So I agree, it's a little bit of a downside, but it's combined essentially with slowing down the release cadence. We get back to a place where it's okay. So yes, you will download more, but you will also download less often. Because like right now, you're offered an update every day, which is just crazy.
Thank you. I'm sorry, unfortunately, we don't have time for more questions, so feel free to talk to the speaker in the hallway. Thank you very much for your attention. Hey, hello everybody. After a small technical break, we're back just on time with the program. Last but not least for today, the speaker from a country of tongue breakers will tell us all about the reproducible builds in Fedora, a very hot topic. And Zbyszek is an engineer, and he's really into the reproducible builds. Like, it's been another talk in the long round of talks about that, and I'm very excited about how it progresses. So let's welcome Zbyszek here on stage, and I'm giving the word to him.
Thank you for the introduction, and sorry for the delay. I think I should maybe consider switching to silver blue or something better. I'm going to be talking about reproducible builds and what has happened like in the last year since last vlog. I'm the only one presenting today, but like actually a lot of the work was done by Jelle, and Davide is also an instrumental person in this effort. So I put them in parentheses. When I was preparing the slides for the talk, I realized that like the basics haven't changed. I mean, should I go over the basics? Is there anyone who doesn't know what reproducible builds are? And should I give a short intro? I think a short one would be good. Being lazy, I copied a slide from last year, right? I mean, reproducible builds. It's incredible that the idea is at least 12 years old in the distro space. It started with Debian. And Debian people have been working on it in a really consistent fashion, doing like the low layer thinking and the low layer improvements in tooling. They have, I mean, depending on how you look at it, 90% reproducibility today. They say 98, but it's in a very, very special definition. They do automated their builds, they have dashboards, they have tooling. I'll be talking about some of that tooling later on. And we are playing catch up. We got into the game very late. The upstream, or well, the official definition of reproducible builds is that the build is reproducible if given the same source code, build environment, and build instructions. Any party can recreate bit for bit identical copies of all specified artifacts. When we try to apply this in Fedora, we hit a wall. There's a few walls to hit there, but the first one is that our packages have embedded signatures, and if you can reproduce the upstream signature just by looking at it, then something is wrong. So we had to update the definition. We say that, well, the artifacts are identical except for signatures and parts of metadata. Also because we discussed dropping some metadata from RPM headers, and the general answer was that people like this metadata there that tells them exactly that a given package was built on build VM 98 and not 99, that it matters for debugging things, and that in principle we could extract this data from somewhere else, but people prefer to keep it. So we have to not look at that part. But we also have to not look at the signature, so this ultimately is not a big issue. And the other part is that the build environment does a lot of work here in this definition, because well, if I give you a source RPM or a source deb, to rebuild it, you need to know the full state of the build root environment that you would get if you started the build. Is it part of the build environment? Is it part of the build instructions? We don't think about it this way, right? We create a source RPM and we send it to Koji, and Koji does the build for us. And we would like to repeat the same thing. We would like to take a random source RPM and repeat the build. And to do it actually in a reproducible way, we need this metadata from the build when it happened. So the exact time, all the packages that were used, and the architecture that was used for the build sometimes, depends. So in our updated definition, we say that the metadata is also fine, and we look at the metadata and we want to recreate the full environment. And the part where Debian is kind of, well, not fully, I mean, where they're doing like a skip, is that for them, they do testing of builds at the current time. If we asked Debian people to recreate a random build from half a year ago, the way they do it, they have a snapshot server, and the snapshot server snapshots the state of the archive, let's say once a day or so. It means that if you are at the right time, you can recreate the build. But if you are at some other time, then maybe some of the packages are already different. With Koji, we have the nice thing that all the builds that were officially, all official builds in Koji that were ever done are available for download. And this is what our tooling does. We download all the builds from Koji and use the metadata from the build environment to recreate the exact same build root contents. What also hasn't changed is that there are like two legs, two motivations. One is security. This is the original motivation. The story is apparently that when Bitcoin was a very popular thing, well, it still is, but a long time ago, there was software, and people wanted to trust that the software that they're downloading in compiled form is actually the real one that corresponds to the source code. And that's very hard to check if you don't recompile it yourself. So one approach that they figured out is to make the build reproducible, and then 5 people can do the build, and then they attest that the client that you are downloading is actually reproducible. So this security aspect matters, but the other one is actually more relevant to us. It's the, like by testing reproducibility, we find a lot of bugs, in particular like packaging bugs, compiler bugs, or maybe inconsistencies, it depends a bit. By doing the whole effort, we will increase the quality of packaging. I think that, I'll show some examples later. I think that they show that this is actually quite true. About a year ago, we added a tool called @determinism to the default build root definition. It's a build root policy script. Well, it's not a script because it's written in Rust, but the name is script. So the idea is that this is a tool that runs by default and fixes common issues in packages when it will be too annoying or hard to fix them in the package spec file itself. So, for example, when we build a static library, since a static library is just an archive, it embeds timestamps of all the files that are the compiled objects and land in the library. And we have 1,000 of static libraries, and they are built in like 50 different ways. So we end up with the timestamps embedded inside of the archive. This is not a problem in general, but it makes the packages completely irreproducible. And what the smart people in Debian figured out a long time ago is that it doesn't make sense to try to fight with that. It's better to add a tool to fix it after the fact. And they have strip non-determinism that is written in Perl. It's a bunch of Perl code that is, well, we don't like Perl in Fedora that much, so now we have a Rust version. Also more positive, right, add determinism. During last year's flock, it was already in place, it was just freshly added. So we have done more or less 2 mass rebuilds with it since then, and it hasn't broken things. There were a few bugs, but actually not that many. I think it shows that writing tooling in Rust is good because I'm not a very good Rust programmer. But that stuff, I mean, apart from like a deadlock bug in logic where I tried to implement an IPC library on my own, there were a few issues like that, but they were high-level logic bugs, not low-level. I mean, you cannot have low-level memory corruption issues, and this is actually, I think, a pretty good result. And over the last year, I added a new handler, so like a new plugin inside of add_determinism that handles zip files. And I put here new in quotes because there was already one for jar files, and zip files are jar files with a different extension. So I mean the actual amount of new code was minuscule. Another one for gzip files, because I mean it's always the same issue with archives, like with static libraries, that we do a build and the timestamp of the files and the ownership of the files that was present in the file system where the build was being done gets embedded in the library, and this is not needed at all and makes things irreproducible. So by cleaning those things up, actually we make the archives a bit smaller and a bit cleaner. It's actually good. And I spent a lot of time rewriting the handler for Python bytecode files, so PYC files. Quite a while ago, people realized that when Python builds are done on different architectures, there are so-called unused reference flags in the bytecode. So the bytecode works in this way that a series of objects is written, and you can tag an object to be referenced later, and then when you would write the same byte stream again later on, you can replace that by a shorter thing that just says reference the previous definition by number. And so the thing that we knew, the irreproducibility that we knew about, was that Python, for some reason, sometimes tags a thing to be used later, but it is actually never referenced in the stream later on. This is because of some internal Python object reference logic. So we would look at this byte stream and figure out if there was a reference that wasn't referenced later and just flip a single byte to remove it. So this was like a relatively simple operation. But then when we did that, we realized that what also happens is that sometimes Python has a chance to replace a part of the stream by a reference, and it doesn't. It's not a big issue. When I implemented this cleaning up of references, which actually means that first of all, we maximize the number of references that are used, and then we remove any unused reference flags. This shrunk Python files, bytecode files by like 1%, 2%, up to a few percent in some cases. So it's not a huge saving, but it's a little bit. Python 3.14 came in, and another thing is that I added, while working on this cleanup of reference flags, I added detailed code to print PYC files. It's not a very common thing to worry about this, but let me show you. So this is the output from the tool. That's how the Python bytecode looks, and there's already two that exist. We have Marshall parser and Marshall dash parser. One is without the one without the dash is in Rust, and the other one is in Python. But I mean, each one does the printing in a slightly different way. This one is done in a way where you can look at flags, and it has Unicode support, so it's nice. I gave a talk at FOSDEM about this. I'll provide a link later. So there were some changes, like in the low-level add_determinism implementation. And we also made a change proposal to, with the title of package builds are expected to be reproducible. This is accepted for Fedora 43. when submitting the talk, I thought that we would be actually more advanced in this. Things didn't go as smoothly as I hoped. So we are certainly not at 99% yet, but the plan is still the same. Like maybe we'll even make it for 43. I'm not sure, but I still hope. So like going backwards in this list, what is happening right now is that a few people work on like the tooling to make builds and to check reproducibility, and then when issues are found, they are maybe reported somewhere, but in general, this is done by a very small number of people. And to actually make this like this 99% or 100% level, we need to get individual maintainers involved, and to do this, we need to build tooling to make it easy to, well, maybe not easy, but at least not that hard as it is right now to do this. So we want to have a web interface where you can check the status of your package, look for other packages that have the same problem, and we want to have a CI-like system that does this, and that at that point we can start opening bugs against packages and asking people to fix their packages. And the good thing is that a lot of this infrastructure is available and has been done by Arch, has been done by Debian. So it's a question of adapting it for our for RPMs and Koji builds, and well, putting up the infrastructure. So the big tool is called Rebuilder-D. It's an Arch Rust tool to do rebuilds. And it works like also a bit like Koji, right? There is a service that fires off a timer, let's say once a day, does builds, and the builds are done by workers. In our case, well, they are done by workers, and then the workers post build results back to the service, and it puts up the stuff on the web. In our case, the rebuilds are done using a tool that I wrote called Koji Rebuild. It's a wrapper around mock, and mock is a wrapper around nspawn, and nspawn is a wrapper around, well, DNF and RPM build and the spec file. So yes, well, like the parts below Koji Rebuild are standard Fedora tooling, more or less. The big difference with the way that builds are done right now is that now when you do like a mock build locally, you get the state of the like the build that you get changes all the time, because it is built from whatever is tagged in Koji into the specific build root at the time, and when new packages are built, they are added, and so on and so on. And what we want to do instead is we take an RPM build, we query Koji for the list of RPMs that were present in the build root for that build, and Koji has this recorded. Then we download each RPM from Koji, because all RPMs are not available on mirrors, so we have to talk to Koji directly. And then we prepare the build environment for mock, where only the packages that are on this list are available. And then when mock looks at the source RPM requirements list, build requires, it finds just the packages that we provided. So it installs the build root with the same package set that happened in the original build, and then the rest is the same as before. I mean, normal. In the meantime, there has been some work on hermetic builds, like from the Conflux project. It's kind of the same idea, independent implementally in a slightly different way. It's likely that we can switch to that other implementation, but that's actually not a big problem. And Rebuilder-D has been packaged for Fedora. You can, I mean, I think it's like the last package was being reviewed. I'm not sure if it's available, but it will be available in Rawhide very soon. As usual with Rust, it's the main package and a bunch of dependencies. And we have a very early environment with Rebuilder-D running. Do I have a demo? Well, last time I checked, so this is Jelly is working on this, and like I checked an hour ago and it wasn't reachable, so I think something happened. It turns out that actually doing rebuilds is not that much work. I mean, I have a server where that has 64 CPUs and 250 gigabytes of RAM, and you can do 10 mocks in parallel, and this keeps up with the speed that our native mock is running with. So because in the rebuilds we skip tests, so that's cheating a bit. But the hard part is disk requirements. Like you immediately run out of space for the builds, and this is actually a bigger problem than the raw CPU power. And every once in a while you get a package that actually uses so much memory that the machine crashes. I haven't solved that part yet. This Rebuilder-D instance is running and it's doing crunching builds. As you can see here, we have a reproducibility of 26% reported, which is not that great. And this is because infrastructure failures when the package builds run out of disk space actually are reported as irreproducible here. So it's better than that. But the good thing is that you can get the logs, you can get defoscope output, and then I mean it's just a question of fixing issues. Yes, so like some of the packages are not rebuilt there. We still haven't found an official home for this, and I mean, it's a very early preview at this point, but I think we can make it happen. And now I want to talk a bit about some specific failures. Before I do that, if there's questions, then or I should add something, then please let me know. I prefer to do that now than wait until the very end.
Hello. If you say that we will have reproducible builds in Fedora 43, does it mean that Koji will have some mode or will be switched to the mode of reproducible builds? And can I, as a maintainer, kind of verify that my package is reproducible on my local box, like reproducing the build done by Koji?
The idea is that nothing changes with Koji, because what we want to do is we want to be able to independently rebuild the builds that happen right now as in separate infrastructure. So we don't want to do, like, for example, have Koji do 2 builds. We want to have a completely separate thing that listens to the stream of packages as they are distributed and then does the rebuild. So nothing changes in Koji and nothing changes in the way that we do packages. And yes, you can, you can recreate the build. So one option is to wait for like this Rebuilder-D system to do the rebuild for you. But the other one is to run the Koji Rebuilder script locally. It's a relatively simple Python script that wraps mock. And you can, it works more or less today. It's just not very fast, but like when you do a lot of builds, then, for example, what I do is I take builds from the last 2 weeks in Koji and I repeat them, and they will reuse a lot of the same RPMs. and downloading the RPMs takes time, but of course you can cache them and then you don't download them that often. I mean, like the new ones don't come that often, so with a little bit of caching, this becomes okay. If you take a random build from history and you have to download like at 150 kilobytes per second from Koji every build, then this can be painful. But yes, you can do it locally. So the last 3 builds, like from the last 2 weeks of May until I ran out of disk space. And yes, it could be fixed. I mean, it should be fixed that the handling, or like builds that succeed should be trimmed or stuff like that. This is not implemented yet. We are still at, depending on how you count, 90% reproducibility. So I say 90% because it says that 85% of package builds are reproducible, but source metadata differences. This happens when the source RPM is built on one architecture and then on another architecture, and you get a different set of build requirements embedded. But this set of build requirements is not used for anything, so it's like useless metadata that is there, and yeah, I mean, like, it's not clear whether we should just get rid of it or whether we should say that those, like, we don't look at those source packages. I don't know, like, this is like a not very important issue, I would say. If we exclude that, we are at 91%, and this is, I mean, it took Debian 4 years to get to that point, so I think it's not that bad. And if we look at RPMs, like, because we can look at the package level and we can look at the RPM level. At the RPM level, 93% of RPMs are reproducible. And if we look at the specific issues in the table on the right, so source metadata is a significant issue. There is still a bunch of static libraries. I don't know why. So this is some categorization that is done to, like, match the reasons for the irreproducibility, because many of the common cases repeat. The ones that are problematic are the ones here. I cannot go there, sorry. So payload mods and payload paths, it means that either paths or content of files in the binary RPMs differs, and this is the part that we want to fix. RPM metadata 73, this is a case where RPMs have build requires or provides or stuff like that that differs. This is usually a packaging bug in the sense that the RPM metadata is not created in a stable way. And I mean, usually it doesn't matter, but it's probably not a good thing. I mean, it's almost never intentional. The big one is debug info data, and we still have lots of compilers and other tooling that creates debug data in an unstable way. This is something that is very hard to fix because it needs to be fixed in those tools. I'll give some more specific examples later on. And the other stuff is, well, like there's a long range of issues. And please note that this is done on a sample of a few thousand RPMs, so it's not statistically significant. So for example, if there was more Python RPMs in this, then it would go up, and if there was more Rust RPMs, it would go up. But if there was more mean GW RPMs, then it would go down, and I mean, this number is like not statistically significant. A quick comparison with also not statistically significant numbers from the past. we are slowly going up in the reproducibility metrics, but not very fast. I mean, there's still a lot of issues. I mean, the first version after add determinism was added in the build root had 12% irreproducible, and now we are down to 9. It's an improvement, but not enough. So, what are the specific issues? The link at the top is the link to the project tracker where we track issues that affect multiple packages, and quite a few have been fixed. I have like 3 pages with all the issues listed that are there, even the closed ones. So, like the first few, GNU debug link sections that it was fixed in GDB by when we reported the bug. Static archives, this is fixed by add determinism. There's some Sphinx stuff, some RPM setup stuff that was fixed in Sphinx and in RPM. Java jar files embed build timestamps. This was fixed by also by add determinism. There's some build root path issues, and the big one that affected pretty much all Python files was the PYC file serialization, and this was hundreds or thousands of packages, and we fixed that with add determinism, and then the numbers went up significantly. There is still another issue for Pico files, but only a small number of Python packages have Pico files, fortunately. A common theme is that no-arch packages use the libdir macro, and it's architecture specific, and of course doing it in a no-arch package doesn't make sense. Either it's just some annoyance, or it's an actual bug. I mean, the typical thing is that there is a path that, since it's supposed to be a no-arch path, then readers of those files look in one place, and you build it on a different architecture, and then those files are completely ignored. So those bugs, I mean, they have like different details of implementation in different packages, but they are usually bugs to be fixed because they create actual issues. Golang needs to be fixed to be reproducible. Another issue with jar files was fixed in RPM. There's another issue with Python bytecode files. Like very, very rarely there is a difference in the serialization stream where class variables are in different order in the byte stream, and this is very strange, but it also happens very rarely, so maybe it's not a big issue. Golang packages, so there was a number of packages that had like invalid changelogs, and when you have an invalid changelog, the source date epoch that is set from the changelog is not set properly, and then you do rebuilds, and well, they are not reproducible because source date epoch jumps. I fixed myself at least 24 packages like this. This is very surprising that it happens so often, and people just don't know. I guess people don't look at changelogs that often. So there's like Java packages use xmaven to modify POM files, and this is not stable and needs to be fixed. The QImage stuff it was fun. So I said that this applies to many packages. This one applies to only one package, to Calibre. It's interesting because it does scaling of icons in this way that it opens the icon. It has a little Python script that opens the icon in using the QImage code, and then scales it to a different size and writes it out to a file. And there's some floating point number instability, it's like single bit differences that are not visible, but they are, well, they cause the package to be flagged. And the strange thing is that, I mean, like if this was using extensions, then it would be architecture dependent. But actually, this is just using normal floating point stuff. So I couldn't figure this out. I don't know, like if somebody is an expert in floating point handling and stuff like that, then please look. Okay, unstable hard linking of files with unstable M times. This is another fun one. So in package builds, we run a hard linking step where we replace files that are identical multiple times in the same package with hard links. And this allows the RPM to handle not copy it around as much data. And the way that this hard linking happens is opt-in, so this is done by a packaging step at some point. And hard link looks at, I mean, the files that are identical are found. And it means that identical in this case also means that the modification time of them must be identical. So when we have an installer that installs files and does not, well, I mean, changes their modification time, then the actual sets of files that are hard linked differs depending on how fast the install happened. Like, because usually, like, multiple files are installed during 1 second, and if they happen to cross the second boundary, then they're hard linked, and if they get installed in 2 different seconds, then they don't get hard linked. Yes. So the fix here would be to fix the tools to not modify the M times. Oh, and the funny thing is that the M times, they are afterwards removed. They are clamped to the source date epoch. So when you look at the resulting RPM, everything is identical except some files are hard linked and some are not. And it took me a while to figure out what is happening. Qt packages record the host kernel version. That's, I mean, it's an issue because it affects a lot of tooling, and also it doesn't make any sense to record the host kernel version. People like to do that, like record the date, the local time zone, and stuff like that. I mean, it just needs to be fixed one by one in packages or in the tools. Are language reproducibility issues? Oh, yes. So the documentation for R packages embeds the current timestamp. This can be fixed by specifying a parameter when the R packages are installed. So if there is anybody who works on R packages, please come talk to me, because I mean, this should be fixed by like a mass search replacing R packages. And Haskell library documentation also has this issue that it embeds like a hash of that is randomly generated, and Haskell upstream is working on a fix for this, so this probably will be fixed at some point. So I mean, like at this point we have some open issues and a lot of technical interesting work to happen to fix those. I mean, some are more interesting, some are less. I wanted to show some funny examples. So this is the Qt stuff. So they embed, like, if you look, there's a JSON, and the kernel identifier is embedded there. Another one, a devel package, just in case you need it when using the devel file. And the one that surprised me quite a bit, when this was reported by Jelly, I thought that this must be some bug in RPM or something, because systemd was irreproducible, and this file etc xdg systemd user is a symlink, and it turns out that well, systemd doesn't have a fixed file list. It installs files into a build root, like the install root, and then uses a set of regex to split them into sub-packages. This is a thing I wrote, it's great. And what it does at the end is that it, for some packages, like you need to add prefixes that happen in the files list, so %dir for directories and %doc for documentation, and config no replace and ghost for files. And it turns out that we're applying config no replace ghost also to symlinks to directories. And then depending on the architecture, this thing would match. So file stat checks the destination, and on some file systems, no, not architecture, or file systems. On some file systems, the empty directory would be reported as having a size of 0, and on others not having a size of 0. And depending on that, in the actual install, you would either get the symlink or not. So this is an actual bug that affects users, possibly, theoretically. Yes, and that's like pretty much it. Some final comments. When we started working on reproducible builds like 2 or 3 years ago, there was not a lot of support for this. But I think it has changed over time. I think that there has been an increase in people who want builds to be reproducible. An interesting case, not related to this work, but to the general concept, was the Intel TDX confidential VM firmware. It's signed by it's built by Intel and signed by a key, and that there's just a single key that is the hash of that key is embedded in the hardware, so that the only a properly built firmware from Intel is accepted. And one idea was that we would take their builds and repeat them in our infrastructure to verify that their builds correspond to the sources that they say that they correspond to. I think that this idea has been abandoned because they, for example, use some old Ubuntu version with some very specific compiler version. So it will be of limited usefulness, but it's kind of the same idea. And another thing is that there is some interest in certifying that builds are reproducible for stuff like cards and other special appliances. There's people also working on reproducible builds from that side. And the one that really surprised me was that I got a pull request for add determinism, and then when I inquired for the reason for the pull request, because it was about macOS resource files. And that, this is a quote from the person, that we are using add determinism to handle timestamps generated by mil. It's a Java build tool during the build process, and we want to add support for macOS. So, yes, to build Scala. It's open source, has unexpected uses. And links to. So we have a matrix channel, we have documentation. The issue tracker is the thing I linked to. We have a change proposals and other things. There is general stuff. And if there are any questions, I will be happy to answer.
Thank you, Zbyszek. So do we have any questions?
Just back to the topic of unreproducible hardening sets because of unreproducible M times. Well, they are inherently unreproducible M times. Why are they taken into account in the first place? And when this hard linking takes place, at which stage of the build? Is this mandatory or?
Yes, so going like from the end. And the end of a package build, before we put the files in the RPM, we will actually clamp M times. So this means that you can have M times from like m times from the past, like for example, m times of source files that are copied, they're preserved during the copy, they stay unchanged. But everything that is after the source date epoch, which we set to the timestamp of the last changelog entry, is clamped to the source date epoch. So this means that right before the files are packaged, we clamp some timestamp that are created during the build, and this hard linking happens before that. So this is why, when the hard linking happens, we see the m times that are spread out over the build time.
These BRP scripts are ordered this way, right?
So it's not like we cannot just change the tool to ignore all
at source level m times, and we don't ignore them.
So it's not like a technically very complicated topic, but it requires some, doing things in the right place with the right subset.
Completely, I see.
Yes.
Thank you. Does anybody else have a question?
You mentioned that architecture-dependent metadata on SRPM files was a problem too. And you said you might want to get rid of them entirely. I don't think you can do that, because those metadata are used for generating repo data for the source repos. So you wouldn't be able to query for source RPM dependencies if those metadata were gone.
So there is a few options. One option that I really like is to say, instead of having like if arc build requires foo, you say build requires parentheses foo if, and then you have an architecture list that is, and then closing parentheses. And this whole line is architecture independent. And then this would actually have the benefit that we could query build requires for all architectures from a single set of from a single architecture compose. So this is one option. In some cases, like we found bugs in the source RPM metadata too. So this is like completely ignoring them is not a good choice. We need to figure this out. But it's just a low priority thing.
I think you're going to talk about this on Saturday.
No, there was a different topic.
I just saw that there was a workshop on Saturday about architecture independent RPM build requires.
I wanted to get off packaging scriptlets more than that, but okay, maybe too. Let's put it on the agenda. I would be very happy to talk about this.
Do we have any other question? Something on Matrix? No. All right. Then you can talk to the speaker directly in the foyer. And thank you for the attention. And thank you to Zbyszek for all the new things and all the old things presenting the topic.